The control room of the ESO Very Large Telescope at Paranal. Here, astronomers observe the sky using the advanced capabilities of this high-tech installation in the Chilean Atacama Desert. With great expertise, scientists and telescope operators master the VLT controls and make the difficult observations appear routine. But suddenly, an alarm rings and calls for their undivided attention. This is the ESO Cast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESO Cast. In this episode, we're going to learn about the Very Large Telescope's so-called rapid response mode. The point of this observing mode is to study gamma-ray bursts only a few short minutes after they are first spotted. Now, because the optical afterglow of a gamma-ray burst fades extremely rapidly, the observations must start as soon as possible after the initial discovery of the burst. And the VLT can deal with such time-critical observations better than any other telescope.
Gamma-ray bursts are the most powerful explosions in the universe. Astronomers do not fully understand their origin, but they are thought to be caused by incredibly energetic events, such as the collapse of massive stars. Gamma-ray bursts are so energetic that for a brief instant they outshine the rest of their entire galaxy. They produce more energy in a few seconds than the Sun will in its whole lifetime. After the flash of gamma rays has ended, an optical afterglow can usually be detected for a few hours. Astronomers look at this to learn more about how and why gamma ray bursts occur. Because gamma ray bursts typically occur at a very large distance from Earth, their afterglow is faint. In addition, the afterglow fades very rapidly, so that within a few hours it can be up to 500 times fainter still. Hence, in order to learn more about the nature of a gamma-ray burst and the influence of the explosion on its surroundings, the event must be observed as quickly as possible.
Now, the VLT is perfectly equipped to obtain high-resolution observations of a gamma-ray burst. But before it can do so, the burst must first be discovered. The SWIFT satellite chases gamma-ray bursts with its wide-field burst alert telescope. Once a burst has been discovered and verified, it is immediately reported to the VLT and other observatories.
An alarm at the VLT console indicates to the astronomers that the activation of the rapid response mode has been requested. The scientists have to confirm that the VLT unit telescope can be moved safely, and within seconds all ongoing observations are stopped. Then the system performs robotic observations without any human intervention, except for the alignment of the spectrograph slit. This automated procedure guarantees quick and accurate observations. In fact, the VLT allows astronomers to begin observations within only a few minutes of detection by SWIFT. With events as short-lived as these, this can mean the difference between making high-quality observations and seeing nothing at all.
But the VLT at the Paranal Observatory is not the only ESO facility which carries out gamma-ray burst observations. At the Residencia Observatory, there are also telescopes that can observe these events. The 2.2-meter MPG ESO telescope features the Grand instrument, which takes images of the afterglow simultaneously in 7 different colors. And that gives astronomers further insights into the physics of gamma-ray bursts. In addition, there are 2 smaller telescopes, the 60cm REM and the 25cm Tarot, and these are also located at Residencia. These robotic telescopes are designed to react immediately when they receive an alert on a gamma-ray burst, making it possible to start observing the burst within seconds.
Scientists agree that gamma-ray bursts are associated with the formation of black holes, but until now the exact nature of the bursts remains enigmatic, and more high-resolution spectroscopy data is needed. The VLT offers enormous light collecting power and high resolution. In addition, it is equipped with a suite of high-tech instruments. It is the combination of the VLT's enormous observational potential with ultra-fast response times, which provides data of superb quality to the scientists who study gamma-ray bursts.
The rapid response mode at the VLT will be triggered many more times in the future, and ESO will continue to collect first-class data on gamma-ray bursts. Data which will perhaps one day help to unravel the secrets of the most energetic explosions in the universe. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
What does it take to be a professional astronomer working with the world's most powerful telescopes producing top-notch science? How does it feel to be working in exotic locations and collaborating with astronomers from around the world? Stay tuned to this ESOcast to go behind the scenes of an ESO astronomer at work in Chile. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to another episode of the ESOcast. Today we're going to follow around ESO staff astronomer Henri Boffin to find out what his work is like at the Paranal Observatory in Chile. Now, Henri's work is exciting, but it's also challenging, because it involves traveling for thousands of kilometers between his duty stations. And he has to adjust quite quickly between working during the day, like most people, and working nighttime shifts at the telescope. Now, when he's not at the observatory, Henri works at ESO's Santiago offices. This is where he conducts his scientific research and where he meets colleagues from all over the world.
Early morning in Santiago, the capital of Chile, and a taxi is driving the scientist to the airport, where he will fly to Antofagasta, some 1,300 kilometers north of Santiago. During the flight, Henri takes the opportunity to check his work schedule for the forthcoming days or read scientific papers. On arrival in Antofagasta, Henri and colleagues take the ESO bus to the Paranal Observatory. The first few kilometers of the 2-hour ride follow the coastal road through Antofagasta, but soon the bus heads into the Atacama Desert, where a seemingly endless road awaits the passengers. Finally, after a long and tiring journey, Paranal comes into sight. Even for Henri, who frequently commutes to the observatory, the arrival at this technological oasis amidst the dry Atacama Desert is spectacular.
After the long journey, Henri immediately heads over to the Residencia, which is his home away from home while he is on duty at the observatory. After lunch, Henri takes a quick peek at the remarkable sight of the VLT, which stands out on the summit of Paranal. Now, the coming night is going to be a so-called overlap night. This is where Henri gets to adjust to working at night, and where he's going to meet with his colleagues in the VLT control room to properly prepare for his shift. So, getting some sleep in the afternoon is pretty essential.
After a refreshing sleep and as the sun begins to set, Henri meets his colleague Jonathan Smoker, who will hand over his observational tasks. Several things need to be discussed in order to guarantee a smooth staff changeover, and the drive from the Residencia up to the control building of the VLT offers a great opportunity for the astronomers to talk business. The VLT consists of 4 unit telescopes, and Henri and Jonathan take over the controls of Unit Telescope 1. They discuss upcoming observations and the status of the telescope and instruments until they are confident that everything has been set up perfectly. Once fully prepared for the night's observations, all Henri and Jonathan have to do is wait for darkness and enjoy the magnificent view from the platform of Paranal.
It's the next day, and Henri is ready to take over observations. After having slept until late afternoon in the Residencia, he now prepares himself for his upcoming night shift. Dinner at the Residencia's canteen, or rather breakfast for Henri, gives him an opportunity to socialize with his colleagues before he heads off to the VLT control room. Tonight, Henri performs observations in service mode at the VLT Unit Telescope 1. In this mode, Henri and the telescope operator conduct observations that have been submitted remotely by astronomers from their home institutes around the world.
Observations at the VLT call for the utmost concentration on the part of the astronomer and the telescope operator. Henri carefully follows a prepared observing program and switches between the various instruments. Everything is planned to ensure the smooth running of the telescope, as observing time on this powerful telescope is a precious commodity. Before Henri can leave the control building at the end of his shift, the night report has to be completed with details of the observations. Now Henri can head back to the Residencia for a well-deserved daytime sleep.
His schedule at Paranal is quite demanding, but Henri finds the time to fit in some exercise. Now, the desert around the observatory is quite a harsh environment, but Henri is an experienced runner who is accustomed to the altitude and arid conditions. Later that day, Henri meets 2 visiting astronomers at the Residencia who've come to Chile to hunt for exoplanets using the VLT. Now, for tonight's observations, Henri will act as support astronomer. That means that he's going to use his experience to help the visiting astronomers carry out their observations.
In their hunt for exoplanets, the visiting astronomers will look for the dimming of light as a planet moves behind its parent star. This technique can enable the detection of planetary atmospheres, but such observations are incredibly difficult and require large instruments. That's why the astronomers have come to Paranal to use one of its 8.2-meter telescopes.
After several nights on Paranal, Henri has handed over his observing responsibilities to a colleague, and now he's ready to fly back home to Santiago.
Back at ESO's Chilean Administrative Center at Vitacura, Santiago. Henri switches back to daytime work and studies binary star systems. Working at Vitacura means that Henri can discuss his research with colleagues. The daily coffee break provides the perfect opportunity to share ideas about latest scientific results and findings. Such casual conversations among scientists can often lead to new and unexpected insights.
This is where we say goodbye to Henri and thank him for allowing us to be a fly on the wall during his work. Being an ESO astronomer is demanding, but it's also extremely rewarding, working on one of the most powerful ground-based telescopes in the world. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
The sun sets at ESO's Paranal Observatory. Technicians and engineers have worked hard all day to prepare the European flagship facility, the Very Large Telescope, for astronomers to use. At night, scientists address some of the most important mysteries in the universe with this superb science machine, observing the heavens in exquisite detail. Paranal is dedicated to astronomical observation, but no one can work all the time, especially in these harsh conditions. Everyone at the observatory has leisure time and enthusiastically pursues their hobbies during their free time. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to another episode of the ESOcast. Now, Paranal Observatory is a pretty special place to work at. First of all, it's located in a very remote and arid Atacama Desert in Chile, and it takes hours to drive to the nearest city. Secondly, the work that needs to be performed there isn't exactly easy, and the professional skills of the staff are constantly challenged by the incredible technical diversity of the Very Large Telescope. So this combination makes leisure activities a pretty essential part of life for the staff, because it helps them to relax and to recover from their often highly stressful work. In this episode, we're going to follow 3 Paranal staff members, Fernando Salgado, Stefan Guizar, and Margaret Mörchen, to learn about both their jobs and their hobbies on Paranal.
Fernando Salgado is an electronic engineer at Paranal. Together with his colleagues, Fernando tests and repairs the numerous electronic components of the Very Large Telescope to keep them in working order. This is often far from easy, and mastering the instrument's sheer complexity is a real challenge. During his free time, Fernando's great passion is playing the drums. And at Paranal, he plays as often as he can in the entertainment room of the Residencia to keep his skills up. He also frequently has jam sessions with colleagues and astronomers from all over the world in the entertainment room, expanding and improving his own musical experience. Amateur musicians frequently give spontaneous performances in the entertainment room, enriching the cultural life of everyone at the observatory. Stefan Guizard is an optical engineer and leads the Paranal Optics Group, making sure that the Very Large Telescope has the best possible optical quality. This involves a lot of different tasks, including working on one of the VLT's huge main mirrors during a recoating operation. Stefan's biggest hobby is astrophotography, and some of his images have been used in previous ESO casts. But Stefan is also a top-level water polo player. As his club is in faraway Santiago, the pool of the Paranal Residencia helps him stay fit and keeps his feel for water at a competitive level. The pool of the Residencia is popular with many people, but Stefan is certainly amongst the most frequent users.
But the Paranal Residencia isn't the only place that offers a chance to relax. Next door to it, ESO has built a gym that offers a wide range of activities. Here, lots of people get together to form sports teams, and the gym hall definitely contributes a lot to the social climate at the observatory.
Kickoff for a soccer game at the gymnasium. At about 2,400 meters above sea level, there's less oxygen in the air, making being in shape even more important for players. People who live and exercise regularly at the altitude don't have any trouble, however. In another room, several people practice yoga together, following the instructions of an experienced trainer. Others get in shape by using one of the many exercise machines of the sports hall. Again, the altitude and aridity of the site make exercise more difficult, but the machines still see a lot of use.
The conditions at Paranal make it one of the best places in the world for astronomical observations. There are rarely any clouds, and the climate is extremely dry in the Atacama Desert. Located at 2,600 meters, the VLT can observe for over 320 nights a year. But it's exactly these harsh conditions that make Paranal a true challenge for the sports enthusiasts, especially outside under the blazing desert sun. But there are people that are willing to face the challenge.
Margaret Murchen is an astronomer at Paranal supporting science operations. On the day shift, she makes sure that the telescope and the instruments are ready for the night observations. On the night shift, she performs observations either in service mode or in visitor mode. In order to relax from these demanding duties, she likes to bike at Paranal. In the desert, good sun protection is crucial, and drinking plenty of water is a must. The site offers numerous off-road options, but today Margaret chooses Paranal's Star Track for her excursion. This path leads from the Residencia up to the Paranal summit. Although the dryness and the altitude effects are always noticeable, Margaret typically bikes for about an hour before she returns.
There are many ways for people at Paranal to enjoy themselves during their free time and to relax from their unique but demanding professional obligations. And after they've played, they're ready to continue the world-class work that astronomers have come to expect from Paranal. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
The observations from ESO's telescopes are stored in a huge archive, a vast and complex vault of online information, usually only visited by professional astronomers on a mission. And yet, an amateur astronomer from Russia managed to uncover a veritable gem in the flood of data, thereby winning a trip to Chile to observe with the Very Large Telescope. How did he manage it, and could you do the same? This is the ESO Cast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESO Cast. In this episode, we're going to take a deep plunge into the vast archives of ESO, and we're going to show you how a group of very dedicated and talented amateur astronomers managed to unearth some hidden treasures.
As the world's most productive ground-based astronomical observatory, ESO has many terabytes of data coming from its Cerro and Paranal observatories that need to be safely stored. In addition to using these data for scientific research, ESO often delves into its archive to find raw data that can be polished into breathtaking astronomical images that can be shared with the public. However, turning the raw data into the images that you see is an intricate process that requires technical processing skills as well as an artistic eye. The archive is publicly available, so anyone can go in search of potential images. But aside from professional astronomers and ESO's public outreach team, not many other people have ventured into the vast archive.
So how can we encourage people just like you to go and delve into the archive and to test your skills at producing beautiful astronomical images with professional data? We knew, of course, that there are lots of talented amateur astronomers out there, but we had to find a way to get them excited about ESO's data. And so we came up with the idea of a competition, ESO's Hidden Treasures. The challenge was tough. Find a data set in the archive with the potential for making a visually stunning image and then process the data. As a reward for the hard work, however, we put up a great first prize. The chance to not only visit ESO's Very Large Telescope in Chile, but to actually use it to observe the night sky. Nevertheless, despite the great prizes, we were a little worried that not enough people would be up for the challenge and that many participants would give up halfway. We were in for a big surprise.
The competition opened on 4th October 2010. Participants were asked to upload their entries to an ESO Flickr group that was created specifically for the competition. The competition was promoted via ESO's Twitter feed using the hashtag ESOTreasures and Facebook page by ESO Community Coordinator Oana Sandu. Tweets about the competition from people around the world were picked up by science journalists, creating valuable coverage of the competition in the media.
To our surprise, entries quickly started coming in. By the end of the competition, we had almost 100 entries, which was a fantastic response.
Once the competition had closed, the judging panel, which included science communication professionals and image processing specialists, met to evaluate many images. Several of the entrants submitted more than one image that deserved an award, so the judges made the decision to choose the 10 best entrants rather than the 10 best images. This led to a total of 20 winning images. Russian amateur astrophotographer Igor Chekalin, aka Flickr user Igor FP, caught the attention of the jury. Working from his home in the countryside and with limited access to the internet, Igor's skills and artistic eye won him first place in the competition for his wonderful image of Messier 78.
The data of Messier 78 that Igor has found are really superb, both in terms of quality and in terms of depth. He has processed the raw images with great skill, and he assembled them very well to produce this final image. Igor has also applied some smart post-processing filters to enhance the details of the nebula. The colors are wonderfully subtle. They show the light diffused by the nebula and the dark dust that partially obscures it. In my opinion, this is one of the very best images ever obtained with the 2.2-meter telescope on La Silla.
The competition proved that there are lots of talented amateur astronomers out there who are capable of producing really astonishing results with ESO's observations, just like the pros. And finally, well done Igor. I'm sure you're going to have a great time at Paranal. It's a lot of fun to observe with the VLT. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.